Welcome to our channel. Watch the video until the end. Leave a like and subscribe to the channel to support us. Every photon that reaches our telescopes has embarked on an epic journey through space and time. Thanks to highly sensitive measuring devices, such as the James Webb Space Telescope, we can now finally see the true extent of the universe, and scientists are shocked. What we see in the depths of space is becoming increasingly mysterious. Massive structures, countless objects like galaxies, bright stars, and cosmic nebula tell us a story we still do not fully understand. Today we look further into space than ever before, but what we see is not what we expected. Instead of answers, we find dozens of new questions. Instead of a boundary, we find endless spaces of creation, and the question remains, why does this universe really exist? How big is it, and what is our role in it? Stephen Hawking believed that the universe did not need God's help to exist. Perhaps a God created it. Perhaps it was created just for us to enjoy and explore its splendor. The brilliant physicist was of the opinion that God's help was not necessary to make all this possible. But for him, the universe is a fascinating thing that creates and sustains itself. However, he left open the question of whether it was governed by an intelligence that goes beyond our imagination. The universe is so beautiful, rich, incredible, and precise that it could not have been born by chance. Until now, researchers thought they could tackle this subject with formulas, mathematical calculations, and describe everything in great detail. But this universe continues to shake our science. It overwhelms us and brings us to the limit of what we can grasp with our mind and our thoughts. Centuries ago, people had to face the collapse of their old worldview and their spiritual conceptions. They had to realize that the Earth is round, a ball floating in a cosmos. Today is the same again. We must realize that perhaps we will never be able to explore the boundaries of what we live in. We cannot say with certainty when the universe was created or why. We can only observe, marvel, and try to understand what we see. The incredible journey of light. Did you know that light tells the story of the cosmos? Only through light can we see anything, experience it, measure it, and try to learn something from it. Light travels through the cosmos at the fastest and most constant speed. Today, the observation mirrors of our telescopes are illuminated by light that began its journey at a time when Earth did not even exist. Photons are a kind of cosmic postal system, and these particles of light not only provide us with images, but also information about the composition, movement, and evolution of distant stars and galaxies. We consider the universe as a vast ocean where every ray of light that reaches us is a messenger from another time. The light reaching us from the most distant stars and galaxies has traveled for over 13 billion years over unimaginable distances. This light began its journey when none of us existed, and the stars that emitted it have long ceased to exist. Because light can travel through space and time for so long without changing significantly, we can now look into regions and times that tell us the history of the past of the universe differently. We can see within a radius of about 46 billion light-years on all sides, which means we have a view of a cosmic globe with a total diameter of about 92 billion light-years. We must accept the fact that we might see only a small part of what is really out there. We are already able to see spaces that are barely conceivable for our brain, and the space out there is becoming increasingly unpredictable. The expansion of the universe is comparable to the continuous movement of ocean waves. We continually discover new and surprising phenomena that challenge our imagination and expand our understanding of the nature of the cosmos. The waves spread in all directions. We follow one wave, leave the space of another. Yet we try to find the connections between these waves and these phenomena with our modest means. As galaxies move away, space, already difficult to comprehend, continues to expand. With the new James Webb Space Telescope, we now have a wider and deeper view of space than ever before. The lens of the telescope resembles a navigation instrument that we use to orient ourselves in the potentially infinite waters of the cosmic ocean. Imagine looking at the sea with an underwater telescope somewhere on the coast of the Pacific or Atlantic. We might see cliffs, rocks, open water, and some islands, but how far can we really see with human technology in an ocean that might be infinite? We might be able to describe the wonders of this ocean at some point, but penetrating all the seas of this world at once is almost impossible. Just as exploring space completely, we know the dimensions of our world and oceans and their real extent only because at some point we began to travel the world and see it with our own eyes. From Columbus onwards, we have come to know new worlds, continents, maritime routes, and the shape of our world. One day, when we are able to travel through the cosmos and see it with our own eyes, we will better understand what is really out there, how vast it is, whether there are other living beings, and the true nature of our universe. Until then, we can only make hypotheses and try to unravel the mysteries of the universe. An unexpected twist. Everything seemed consistent, at least for a while. We had a consolidated concept of the universe beginning with the Big Bang, followed by a period of inflation, a rapid expansion. The first clumps of matter formed, and forces came into play that we can describe scientifically today, but whose true strength and power still seem difficult to comprehend. Imagine stars forming in dust disks, an incandescent fireball providing light and heat to a star system for billions of years, formed from nothing but fine dust and a bit of gas. Powerful forces cause such intense rotations that the dust becomes increasingly dense and hot. At some point, at the center of this dust disk, a star forms, in which fusion processes far exceed the output of thousands of Earth's nuclear power plants. The universe hosts countless stars of this kind, and new ones are continually born while old stars decay and hurl their components into the universe in the form of supernovae, from which new stars can form. Trillions of galaxies perform a seemingly endless cosmic dance. Some of them come together in clusters that we can barely grasp with our minds. These clusters in turn form even larger collections, and we probably haven't yet reached the largest structures of the cosmos. Thanks to ever-improving technologies, we are obtaining an increasingly refined view of the universe. We see more and more, but at the same time, we face more and more questions. We still do not know who or what created all this, nor how this symphony of chaos and beauty is held together and coordinated. Our calculations are based on concepts like dark matter and dark energy, and in particle accelerators like the LHC in Geneva, we are trying to track down the building blocks of matter. The answers to what all this is, where it comes from, and how it functions must be found somewhere. The James Webb Space Telescope was meant to be a milestone in the exploration of the universe. Researchers hope to obtain information on the era immediately following the cosmic Middle Ages. They hope to find confirmations of their theories and to discover new phenomena. But what they have seen so far are facts very different from what they expected. We may find ourselves in a moment similar to that of Columbus or Galileo Galilei. These pioneers of science, research, and adventure discovered things that were previously considered impossible. What do microwave radiation and ghost particles reveal? We humans are fascinated. We use every possible source to learn more about our origins, life, and the cosmos, driven by countless questions and our curiosity. We discover more and more, constantly develop new methods of research, sources of action, and ways to draw new knowledge. Cosmic microwave background radiation is part of the cosmic light background, which is considered a kind of glow from the Big Bang and permeates all of space. This microwave light is a silent witness to the birth of the universe and, therefore, a fundamental tool for astrophysicists to understand the evolution of the universe over billions of years. The light we see today as cosmic microwave background radiation began its journey about 13.5 billion years ago, only about 380,000 years after the Big Bang, when the universe finally became transparent enough to let light pass through. It offers an almost unchanged snapshot of that time. One might almost say that the events of that time are forever frozen in this radiation, waiting for us to decipher them. By carefully analyzing this light, scientists have mapped the large-scale structure of the universe, identified variations in temperature and density of the primordial cosmos, and refined our theories about matter, energy, and the dynamics of the universe. However, the radiation continues to provide new fields of information, leaves room for different interpretations, and surprises us. Recently, researchers have found in this matrix of the universe evidence of a universe that preceded ours, from which our cosmos might have emerged. This could also be an early clue to the multiverse, which would once again go beyond the dimensions of what we know. Neutrinos are another valuable source of information. These tiny, almost massless particles barely interact with normal matter, which is why they pass through planets, stars, and galaxies without leaving a trace. They are created during nuclear reactions in stars, during the merging of gigantic black holes, or through the explosions of supernova. They then travel in huge amounts and eventually reach our relatively new detectors as cosmic messengers. Neutrino research is one of the most recent methods we are using to uncover the secrets of the universe. Deep in the ice of Antarctica or in shielded underground tanks, highly sensitive measuring devices capture and analyze these volatile particles. The study of neutrinos brings us very close to the events occurring inside distant stars in almost real time, or informs us about the forces shaping the universe. These investigations and discoveries are essential, not only for understanding the universe better, but also for expanding the limits of our knowledge. As we proceed in this epic quest, it becomes clear that each discovery leads to new questions, each more profound than the last. The universe, with all its complexities and mysteries, continues to astonish us, challenging our existing theories and prompting us to ponder even greater questions about our origins and our place in the infinite cosmos. In this context, astronomy and particle physics play crucial roles, allowing us to explore not just the visible aspects of the universe, but also those invisible elements that profoundly influence the structure and dynamics of the cosmos. Through tools like the James Webb Space Telescope and neutrino research, we can come closer to answering some of the most fundamental questions of humanity. The enthusiasm for these scientific adventures grows as we expand our technological and methodological capabilities. Every new observation or experiment, whether it confirms our existing theories or contradicts them, is a step forward toward a deeper understanding of the universe. The exploration of the cosmos is not just a matter of science, it is a journey through the history of time, a collective effort that unites curious minds from around the world in the common pursuit of answers to the deepest questions of our existence. So as we gaze at the stars and marvel at the images that the James Webb Space Telescope sends back to us, let us remember that each tiny light in the night sky is a part of a gigantic puzzle that humanity is just beginning to solve. And every photon we capture is a messenger of ancient and profound stories, testimonies of a universe that is, perhaps, infinitely larger and more mysterious than we can currently comprehend.